Okay. I think I'm live. So today is Friday. I think with this topic, actually, who am I and where am I here? Christina, I am Christina, data scientist, been doing this about 12 years. I'm studying some deep learning concepts this month and taking the time to hold myself accountable to showing up and working on it every single day for a little bit of time, um, a little bit at a time. And this week we're doing Cuda programming and trying to understand how to use it in relation to deep learning models. And that has not been an easy task. Like, I'm understanding it, but there aren't a lot of resources to learn it in a cohesive manner. And so that is definitely slowing me down. Um, so I think today the best use of the time, because I didn't like yesterday's tutorial, um, because it didn't really explain to me what it was trying to do, and I kind of need that context. And so I figured today I would go and read some of the documentation and open up a new notebook and go through this programming guide as well and see what is there, at least around the programming model, and just make sure I understand how to do that. This is a gigantic book of all the extensions. It's on the website too, but this is supposed to be a gigantic ordered guide if I need to ever print it. I figured it'd be easier to look at the index here too. And so we're just going to go back and forth and try to put together a model. So I also wanted to pull up the Jeremy Howard video and look at some of what he was doing and see if we can't replicate it easier.
Do more and more of this stuff.
Um, and just start there. And every time I come to think of like Cuda and GP program, my brain hurts from the math. And I know, data science is math. I get it. It's just not the same. So we are going to power through. Uh, power through. That's all we can do. I'm not gonna. I want a Linux computer. I think Windows is just going down the toilet. And I switched to Windows because when I was freelance consulting, um, meeting client requirements, needed a Windows. And I might just keep a Windows for that type of thing, but I just need my personal computer to make more sense in life. Okay. So this is his notebook, and we have the importing of the image that he was talking about and the additional C++ extension utilities, which I pulled up. And I'm just going to go through some of it. Okay. Okay. Let's look at this. This is what we went through with the, actually I might need to pull up a number. Okay. So this is that whole creating a block thing. I think that's a concept I really need to understand. So ignore this is, yeah, ignore my YouTube. That's embarrassing. Okay, YouTube, Cuda, blocks. Okay. 11 years ago. Anything more recent? Ooh, this is illustrated. It's Udacity. Maybe we should start with the oldest one and maybe it's still good.
The Infinity QX60 was clearly designed to make an impression, and my first impression is...
G'day all, welcome to another Cuda toot. So, in Cuda we usually launch many threads in groups of thread blocks that form a grid. That's good. Let's say we've got two arrays right here, array 1 and array 2, and we want to add the values in array 2 to their corresponding values in array 1. Perfectly normal thing to do, quite common, but this is how you might tackle it in C++. You'd use a for loop, possibly. So for int a equals 0, while a is less than 6, a++, then you just add them, the elements one after another, and it might look something like this. So the for loop would iterate 6 times, adding an element each time. That's the way that C++ works. In Cuda, on the other hand, what we sort of do is we make 6 threads, and each thread takes care of a single addition, and they're all performed at the same time. So instead of a loop of 6 iterations, we make 6 threads. Let's have a look. Bang, something like that. So maybe the first thread, thread 0, would take care of the first addition, and the next thread would take care of the second addition, etc., etc., etc. But they would all run at the same time, sort of. Yeah, so this is kind of the hello world of Cuda. This is just kind of the most basic use of the GPU. And we'll code this at the end in an example. It's pretty cool, actually. Okay, but before we get to coding, we've got to go through 100 million terms. So let's just get stuck into it, shall we? Threads. Threads are a single execution unit that runs a kernel on the GPU. So they're similar in many ways to CPU threads, but there's usually more of them. And they're sometimes drawn in the NVIDIA documentation, for example, as an arrow with a squiggly line, just like that. Little thread. Okay, thread blocks are a collection of threads. So all of the threads in a single thread block can communicate. Yeah, it's just a whole bunch of threads all together and they can communicate. So here I've drawn out a little thread block. It's just a square with 8 threads inside it. And all of the threads in the same thread block can easily communicate. And the grid, when we launch a kernel, we launch a collection of thread blocks. And each thread block has a bunch of threads in it, like we just said. So the grid itself is a collection of thread blocks, and thread blocks are a collection of grids. Thread blocks are a collection of threads. Oh, I'm going to lose it here. Okay, the grid might be drawn something like this. So here I've got, 4 little thread blocks, and each thread block has 8 threads in it. Okay, that's cool. DIM3, yeah, it's another term. So the DIM3 structure is really, really important in Cuda. It's just a little structure with X, Y, and Z as integers. And yeah, you can initialize them like this if you want. So DIM3 threads, 256. That's going to make a new DIM3 instance called threads with X set to 256. Y and Z, the other 2 dimensions of our 3-dimensional DIM3 structure, will actually be set to 1. And the reason for that is that you multiply the dimensions quite a bit. And if they were initialized to 0, anything multiplied by 0 just gives you 0. So, that would be no help at all. So they're initialized to 1. Or we can initialize both x and y with something like this, dim3 blocks, 100, 100 in brackets as my parameters. And that's actually going to initialize x and y to 100, but z's still going to be 1. So here my dim3 structure instance will be called blocks. Finally, if you want to initialize all 3 dimensions of your dim3 structure instance, you can put 3 values in the brackets, so 10, 54, 32. This is going to make a dim3 structure instance with x set to 10, y set to 54, and z set to 32. Yeah, we'll see dim3s a lot more. Anyway, kernel invocation. The host calls a kernel using the triple chevron notation. Yeah, chevrons are just a less than and greater than symbol, so less than, less than, less than, and then, something there, the launch configuration, then greater than, greater than, greater than. Inside the chevrons, we place the number of blocks and the number of threads per block that we want to run the kernel. Yeah, so the following would launch 100 blocks of 256 threads each for a total of 25,600 threads. Yeah, these numbers just here, the number of blocks and the number of threads per block is called the launch configuration. So something like this, some kernel, that's the name of my kernel that I'm calling, and then open up the triple chevrons, and then 100. That 100 just there is the number of blocks to launch, and the 256 is the number of threads per block. And then you close your triple chevrons and you put your parameters in brackets. I've just put ... there, but that would be your parameters. This one, on the other hand, would launch 50 blocks of 1,024 threads each for a total of 51,200 threads. Yeah, so you just put the blocks first, number of blocks first, and then the threads per block. And collectively there, you've specified the size of the grid, really. 50 blocks and 1,024 threads per block. That's my grid. You can also launch kernels with 3D grids and blocks.
Where is it? Okay, so I know we watched this earlier this week, but I want to go through it in my head. So let's say we're looking at the MST data set, and actually I'm going to pull in a different data set now, I think. We get it. We extreme valve. They unload it into these parts, right? So if we do that, give it a seed. This is Python. And that is without the Cuda. Okay. So if I wanted to do the same thing, CPP source, torch, map wall, tensor M, 2 tensors, net multiply. Okay, and then you load this and do map wall. Oh, I am blind. I keep forgetting that too, glasses. Okay, and make this screen bigger. I know you're like, how can she not see it? It's on a big, well, you can't tell it's on a big TV, but it is on a big TV. Or monitor. Okay. So then, okay, so I need to run back here. And let's look up some C++ references. So this initiates a kernel, which creates us 2 blocks, which makes us a grid. So these are the dimensions we've been talking about for the past few days. I need to know what C++ void is. When used as a function return type, the void specifies does not return a value. Okay, so there's like, it's like saying there's no return at the end of the function. Like instead of like return something, like in Python, like the word return, it's return nothing. Okay. But it's returning an output, so I don't understand. Okay, let's see. Void. It point to any variable that's not declared. Okay, so not a member of a class or a static member. So how do you know the difference? Okay, so this is a void function return with no return statement. These are other void options. I don't think this is it is a function, wouldn't it be? In C++. Global kernel, void, function name. Let's see. A cast of void can have semantic effect in one case for values. Okay, it means, okay. So I don't have to have it there. And it's just for readability. If they're not returning everything, I guess. This is the function name. This is declaring the type float, 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 int. I'm so glad I don't have to do that in Python. Whew, that kills me. Okay, so this is going to get an integer once you do all of this. Now, if r greater than h and so now r is this thing. No, r is here. This is, I'm an idiot. Ignore me, ignore me. R, integer r is here. So if r is greater than h, which is passed into a function, or if c is greater than w, then return it. It's fine because they have to be of same size. So that's just a size check. We saw that in Enumba. We have float o, which is declaring a new one that's an internal variable. And now we're going to iterate across the array. So we have to start at 0. This is looking at the index, m data ptr, n data ptr. I don't know what data ptr is, so let's look it up. Cuda. Let's see. Oh, it's a PyTorch. Okay, so now we're looking at a PyTorch operation returns the address of the first element. Okay, so that's where we see the first PyTorch, it looks like. So, because it can be used together. So we get the first element of the tensor, output, add in those numbers, launch that it checked, return output. Output is here. Whatever happens in the subsequent activation layer. A subsequent activation layer. Okay, So let's do this. I need a data set. Let's see what PyTorch data sets are available. I might as well get it from the same location if I can. Okay. Code samples. Maybe I can't. And if I can't, I will just go to oh, it's just here. Big old. I don't want to use the same data set. Because I feel like I read code and then I'm just like, okay. Okay, so let's see if we can. Kaggle deep learning data sets. Okay. You want a computer vision one? Ew, plant disease. Okay. Export metadata as croissant. Copy API command. This may or may not work. Okay, let's go here. And I'm sure I'm missing something. Kaggle API instructions. Okay, for downloading data sets. Making sure there's nothing else. Okay. I'm not going to bother authenticating. Okay, so let's just use the command line and see if this works out fine. Oh, I have to be in a GPU. Okay, it's downloading. It downloaded. Change runtime type. Okay. Let's see. Folder, sample data. No. This is a zip folder. So let's just see unzip. Let's look at this code. So let's do a few things that he did. So one, this is going to give me a zip file, not a pickle. Let's get URL retrieve. It's in the /content place, which I'm sure if I understood how Google Colab work, I could find. Oh, here we go. I don't see nothing that says anything about potatoes. Data lab, web, nope. Said to content. I'm in content. Unclear instructions. Okay. Tis fine. So this is what we'll do. Let's bring over what he did here and see if we can't replicate it a little bit better, put it somewhere where I can find it. Okay, so this downloads a special type of zip file, right? So what we're going to do is, this is the dataset URL. Okay. We're gonna just make it URL. Okay. It's gonna create a data folder if it's existing. Okay. It's just gonna make directory and it's gonna call it potato. Let's see if that works or if I need to change some things. Oh, yeah, it's good to run your installs. HTTP4 error. File not found. Okay. Because if it's actually, if I refresh this, will it pop up? No. Okay. Let's see if we can do this a different way then. If I can't just do that, let's see. Okay. That's not what I want. Okay. Thank you, person. So much to do. Okay, this is 6 years old. Modern stuff. Okay. Right. It's already there because that's not the issue. Okay. Let's mount Google Drive to Colab so I can access stuff. Okay. If this works, I won't need the other imports, so I'm going to get rid of that. Connect to Google Drive. I have no idea. Continue. Said to refresh. So, okay. Done that. I feel like that camera's right up on my face. It's not getting flattering angles. Okay. Next. I didn't upload a file, so what did I miss? Not do. Okay. I didn't upload anything yet. Okay, I guess I can upload it. This seems like the most roundabout workaround. Like, why aren't we using Kaggle download? I don't know. Yeah. I wonder if they're giving like 3 different ways. I'm just not reading this. I'm very bad at reading directions. I'm just going to let you know. Yeah. Let's see if it actually unzips. Okay. Because honestly, that would be easier if it just unzips. This is the path. Copy selection. Okay. Cannot find. Okay, let's do this again. Trash, trash, trash this one too. Download. Unzip. We have movement. Okay. Now let's refresh. Aha! There we go. Okay. So, as I said, it seems like this other route was like not the way. Not the way at all. Okay. Now, got that. Let's go back to this notebook. I'm going to clear output. Okay. And I don't need any of this. Oh, yeah. Don't need any of that because those are all command line tools. Okay. Now let's go back to here. Don't need any of that. Actually, this automatically unzip, train, and test it. So let's look at the data available to us. I don't think any of it's marked like that. Train or test sets. Late flight, early flight. And actually, let me make sure I read the data. Because one of them might be intended for a train set and one might be intended for valve set. And where's Gaggle? Exit. Oh, here it is. Okay. Contains potato plants, early, late, healthy leaves, curated. Okay. Plant village. Got it. But that doesn't tell me any metadata. This is the data card. So let's do this. This data needs to be split into something. That's for sure. Guess that's why he used the MNIST. So much less work if it's already split up. Or he put it all in there as okay. So we're going to create us a training set. And we're going to randomly select a bunch of files. Actually, I could probably just use the image from the internet in my validation or just to pull out. So let's do this. My brain doesn't want to think about coding. It's like the wrong time of day for it. Okay, so we have 3 files. I need to go through the file and call it a training set. It's going to be with something, that's for sure. Not what I'm trying to do. I don't want to have to use my brain. I want to just come on, give me easy code so I don't have to think. Yeah, that's a bad idea. Okay, let me just get the base code for files. With the with statement, please. Okay, just need the syntax. Okay. I need to open a folder actually. Here, his code. Actually, what am I doing? I can just copy his code, but I just need to convert it to 4 files. Silly me. So, this is just loading a pickle file. Or I could do this a really lazy way. Not recommended you do it my way though. Is it all tagged? It's not tagged. The names. This is what we're gonna do, I think. Let's make sure that's the same. Like, it's really not tagged. Now, this is low blight. And what is this? RS early. Okay, so it is named. They are named. The images are named. This is what we're gonna do. We're gonna do this Christina's lazy way. And we're going to see if I can usually can select in a file folder. I guess not. Google's outsmarting me in file selecting. Can't select all files. Dang you people. Okay, fine. Let me get off of the GPU while I figure this code out. So I'm not holding up on one. Okay. I don't need to be subscribed to Google Colab for. Oh man, now I gotta load all those files back. Okay, that's fine. Here. Okay. Refresh. There we go. Okay, anyway. So I'll clear the contents out again. I guess we are going to be using my brain So I'm going to open a folder in Python. Maybe I do want to do this a different way. Never know. I hate all of the decisions. At least my mind does when I'm not in a coding mood. Okay, let's do it like this. Well, let's see. I think this way is the laziest way. I'm going to try that first before I put in more effort. Thing about coders. The reason why there is code is because we don't want to do it by hand, right? So Alan Turing, have you ever seen the movie that was made off of like a fictional recap of his life during World War II, right? He was not about to manually code break. He was like, y'all's crazy. They're using a machine. We need a machine. Why y'all trying to do this crap by hand? And so that's how we got computers. So number one lesson of being anything related to a computer scientist, your job is to make the thing easier to do, not to make it harder to do. So if we're going to make it easier to do, we want to go the path of least resistance. So find the method to do that. That's all. That's why we're coding. And that's why things keep getting faster and more succinct. That's why we got GitHub. They're like, why are we doing this by hand? And oops, let's see what I did. Why are we doing this by hand? Well, that's why I don't have to do it by hand anymore. Potato not defined. Potatoes right here. Maybe I'm in the wrong folder and it's not actually pulling the right folder. Subfolder. That's that. That doesn't make sense. This is Python. What's this path? Yeah, hold on. Things it doesn't tell me. Data zip. So this is code from the same directory. And I have a feeling that this directory is not the same directory. I got a feeling. But tonight's gonna be a good night. Tonight's gonna be a good night. No, it's the same directory. So if it's the same directory, why is it not defined? Nice. It's literally right there. And you see it. So I don't think that's going to change anything. Why is it not defined? Now I'm going down a whole new rabbit hole, hoping for an easier, less code way. It's coming back to bite me. Oh, it's not a directory. I was looking with the zip file in the first place, so I'm distracted. Yeah, it's still in the zip file. Oh, silly me. I feel like I always read over the most pertinent parts of everything. The most pertinent parts of everything. It takes me twice as long because I'm not a detail-oriented individual. Okay. There we go. So now, let's see if it worked. All potatoes. No, it didn't work. I'm gonna delete this. It didn't work because it just put all the folders in there, but I wanted to copy without the folders because I don't want to loop through folders because I'm lazy. Alas, I don't think there's any stop. Delete folder. Yes. Making my life difficult. Okay. So now I'm actually gonna have to do this the long way. I don't want to do it the long way. Okay. There we go. Walking in directory tree and printing the names of the directories and files. So we're going to not walk the directory. Well, we're not going to print it while we walk. So this doesn't work. Okay. So this is going to give us the walk we want. Is there... I'm going to end up needing to define those two things. Okay, I guess I'm just going to have to create it. Or unless it's just automatically defined. Okay, yeah, okay. Not what I want, not what I want, not what I want. Stop. Okay. Great. all this to maybe get started on Cuda. Maybe I should just follow the tutorial. Because this is the right folder. I don't want to print. Okay. And hold on, let's see if these names is 0001. And what is this first one? Down here. They're the same. 0001187. Yeah, someone just put in there. Okay. And let's okay. Let's try this. Okay. We don't need to actually walk anything. We just need to move it. So we're going to doesn't have. Well, that's what I'm looking for. That's not what I want to do now. I want to delete all. This is probably the worst way to do it. Path. Okay. Copy path. Right, it is a path. I'm just trying to remove it because I don't like a cluttered workspace. I feel like I'm not going to get anything done just because I'm setting up everything. Okay, did it work? Didn't look like it froze because you didn't even reload. And let's save and reload. File folders. Didn't work. It doesn't look like. Nope, didn't work. Oh, end inbox. Ha 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 ha. See, me and not being detail oriented. I bet you guys saw that too. Not even telling me. JPEG. Well, guess it really didn't work. Let's see. I wonder if it's caps lock sensitive. I don't think so. I think it's just not working. Okay. It's going to really annoy me to death. I can't clean this folder up. Okay, well, it's 7, so you will resume tomorrow. And by that time, I probably still wouldn't figure this out. But okay, guess this wasn't a Cuda lesson. It was a lesson in getting rusty. All right, see you guys tomorrow. We'll come back and figure out what to do to clear out the folders and to start implementing from copying and pasting code on a new data set from Jeremy Howard's Cuda training to see if I can't replicate and understand that code, but in context.